Well, good evening, everybody. Welcome to Charlotte IoT, our new online presence during the little vacation we've got going on here. Tonight, glad to have you. We are going to be talking about AWS Greengrass, their new IoT Edge product. Just a couple quick opening remarks. We are a group of over 2,000 members. Someone should update his slide. Proudly sponsored by Pratt Miller. Like to take a moment to thank everybody on the board. As you can see, there's a lot of people behind the scenes that make this happen. Dan, our fearless leader. Me, who's just hanging around. Graham, Mark, Rob, Christoph, Joe, Glenn, Leslie, and Mike make for an awesome group and definitely keeps everything going. A big shout out to our partner, Pratt Miller. Just everything IoT awesomeness, data analytics, awesome machine learning that they do. And obviously they're into that industrial revolution 4.0, which, just makes absolutely everything so much more manageable, using data analytics to track everything we can. A couple little projects they've done. This is their UTR systems implementation, humidity control. Just, some eye candy in here. We do got some game here at Charlotte IoT. And obviously their new palette systems that they're working on. Tons of machine learning here. Just absolutely awesome. Just a note, the dates are wrong on this slide, but we are having a Developers Day with Riot. Riot is another partner of Charlotte IoT, and we do an amazing amount of cross-population with them for different events. They will be doing 4 half-day workshops for their Developers Day coming up in September. I'll be speaking about reliability there. You'll see a lot of other vendors speaking about everything IoT. So definitely worth coming out to see. So tonight we've got Neil and Vijay from AWS, and they are going to be talking about AWS IoT Greengrass tonight. Just a couple quick things for housekeeping. In the chat in YouTube, if you got any questions, go ahead and pop them in there. We will see them back here on our back end. And also, if you are seeing this and it is not live, you're seeing a recording of this, don't be afraid to make a comment down below. We do keep track of them, and we will do our best to answer those questions. So this doesn't have to be all about today or tonight. If you've got questions, go ahead and put them in those comments, and we'll definitely work on getting you an answer. And also, hey, click that like and follow us. Charlotte IoT definitely doing some work to get us online and get everyone else excited about the Internet of Things. So without further ado, I'd like to bring on our AWS gentlemen. We've got Vijay and Neil. I've met these guys at re:Invent last year, and I'll tell you what, impressive. So definitely looking forward to this tonight. And without further ado, I shall go ahead and pass the mic over.
Thanks, Jeremy. Good evening, everyone. We have been planning to have this event for a while, and we really wanted to have this live and wanted to visit you all at Charlotte, but unfortunately, we're living in a different world now. So a little bit of change, but yet we're having this event. So I'm glad that we finally are doing this. So my name is Neil Sendas. I am a Senior Technical Account Manager at AWS. I'm also a member of our IoT technical field community. And the technical field community is a target group of AWS employees across all geos, and that includes members from various roles, including solution architects, pro serves, our consulting practice, and technical account managers like myself, business development managers, marketing, all these different roles, right? So the TFC program, it is a service that supports and drives active community contributions and scale technical knowledge through events such as these meetups, and that's how I participate in these meetups and help evangelize knowledge about AWS IoT Greengrass in particular today, right? So we'll be spending next hour and a half talking about edge computing and AWS IoT Greengrass. With me, I'm joined by my colleague Vijay Rao, will show you a demo of IoT Greengrass as well. So he's built a quick demo, and we will be sharing a GitHub repo with you as well that you could take with yourself and build yourself after today. Right. So with that, let's go over the agenda. So what are we going to cover? We're going to introduce edge computing, talk to you about why we need AWS IoT Greengrass and edge computing. Then we'll spend a good amount of time doing a deep dive into AWS IoT Greengrass, talk about the different building blocks of AWS IoT Greengrass, and then I'll walk you through the console real quick. And then Vijay will do a walkthrough of the demo setup. Yep. And with that, let's get started. So,
Neil, are you, sorry to interrupt, are you presenting the slides?
Yes, I am actually. I'm on my third slide yet. Can you guys not see it?
I got it here.
Okay, sorry. Go ahead, Neil.
Cool. Awesome. All right. So what is edge computing, right? We've all heard this phrase, right? Living on the edge. What does it mean? It means, you're living lifestyle that's not quite traditional, right? You're not following the norms as such, right? In the cloud computing sphere, edge computing, with respect to what we know as cloud computing, means somewhat very similar, right? It's computing, but not quite in the cloud, but it's very close to it. Maybe something close to the fog, right? So simply put, edge computing enables you to process data closer to where it is created. Now you have lots of devices generating millions and millions of data today. Can we process these messages close to where it is generated, right? Instead of sending it to the cloud. That's what edge computing is. And that's where we need the concept of edge computing. Now, why edge computing, right? There are several reasons, and there are three main reasons for why we need edge computing. Because 70% of the data that's created today is not worth saving. You process the data, possibly close to where it is generated, and only save the ones that is worth saving, right? And those are the ones that you send to the cloud. And three main reasons are laws of physics, laws of economics, laws of the land. Let's go over that, right? So laws of physics, what does it mean? Now, you have to follow the laws of physics. Like you cannot get, for instance, you can't go faster than speed of light, right? If you want to process computer images that your autonomous car are the car is viewing these images from its camera, and then you want to take a decision on whether to take right turn or a left turn, you can't send this data over to the cloud to process it. Simply, physics doesn't allow. The latency is just not unacceptable. It's not acceptable, right? So that's where the laws of physics come in, and you'll have to obey those. Then laws of economics. What does that mean, right? Now, over the years, the last couple of years, the cost of networking has fallen drastically. However, the cost of data storage has not been able to keep up with that. Moreover, you'll have to transfer that data, and you have to pay the data transfer charges as well as you move the data over from your devices or your edge devices to the cloud, right? So you'll have to pay data transfer charges. If you could process the data on the edge and not send to the cloud, you can save the processing cost. And then of course all that bandwidth and the message cost, all of that can be avoided. So that's laws of economics that restricts you from sending everything that you generate over to the cloud. And finally, laws of the land. Now, there are certain data that you cannot possibly send to the cloud due to, let's say, regulatory reasons. Financial industries, highly regulated industries cannot send certain stuff, even medical records, for instance, from a hospital. You probably have regulatory reasons not to send it to the cloud. You want to process it close to where it was generated. And that's why you need to use computing capacities and computing technologies like edge computing. And that's where Greengrass comes in. Now, before I get into Greengrass, it'll be useful to show you a little bit about IoT, AWS IoT in general. And then you'll be able to compare and contrast and appreciate why we need Greengrass even better, right? So let's talk about the AWS IoT platform. So what is it? What is AWS IoT platform? It's a managed service that allows you to process messages from devices on the cloud, right? So let's look at this diagram here. You have messages generated by this turbine on the very left, and these messages are transferred to the IoT platform. There's a device gateway, which allows messages from all these turbines to come to the IoT platform. Then you're going to use either IoT, you're going to use MQTT or HTTPS or WebSocket, whichever you want, to send these messages over to the device gateway. And then it manages all the incoming messages. And each of these devices, the turbines and multiple turbines in the wind farm, they'll each have to be registered in a device repository, which you see on the right top left bottom, right? That's a device registry. As the name suggests, it's a registry of devices. We would like to make sure that the device that's connected or is trying to connect to IoT is registered, and we know which device it is and what certificates it's going to use, all of that. So once a message reaches its device gateway, through the device gateway, it's processed by a rules engine. That's the next step. The rules engine sends messages to various AWS services. This is your integration point, where all the messages coming in from the through your device gateway are processed by the IoT platform. You can have multiple rules processing the same message, and these rules can send the messages over to any number of services. DynamoDB. You could send it to Lambda functions, Kinesis, CloudWatch, machine learning, all of that. And one of the most frequently used services, AWS Lambda. Like, as you know, like Lambda is used for event-based computing, right? And you can also trigger machine learning inferences hosted in our machine learning platform or machine learning service, the SageMaker, Amazon SageMaker, you could send these messages over to SageMaker for processing, or even DynamoDB for storing, QuickSight for visualization, all of that. So rules engine takes care of that. And then there is this concept of a shadow service that allows you to keep AWS IoT to track device changes. So let me spend some time on the shadows, because this is a little unique to AWS. So what is a shadow? So let's say you want to control lights in your house, right, using a mobile app that you have built. And if you follow the diagram on the very right corner, there's an application, all these applications, the tablets and the mobile apps and all that. So you have this app. It's trying to control the lights in your house. Now the apps cannot directly talk to the device, right? It will have to send these messages or its desired state to a certain intermediary state, which is, let's say it says switch off the light or turn the light green, right? That it sends these messages to something called a device shadow. And that's the device shadow is the one which manages the state, the desired state versus the actual state. So now let's say you send your desired state to the device shadow. It is managed through a subscription topic. You send the message over to a topic, and then there are subscribers to that topic. One of the subscriptions would be the device itself, the actual device. Now the device is, let's say, offline right now. It cannot connect to AWS IoT. And next time when the device connects to IoT, it will collect that information from the shadow topic that your application has sent, and the device is subscribed to it, and it'll find that the desired state is, okay, I want to switch off the light, or I want to change the light color to green, right? So that's where the device accepts that desired state and acts on it. So in other words, shadow helps you with the command and control operation programming model, right? So those are the key components of AWS IoT. Now, so now you understand the value of edge computing. What is it? Why do we need it? At AWS, we asked, how do we bring this power of AWS IoT to the edge, right? And how do you make sure that we can process all these messages close to where it is generated, and yet use the power of our IoT platform? And that's where Greengrass was launched. And so, as I mentioned, Greengrass, it's our edge computing platform. It brings the power of IoT to the edges. You can use the same paradigms that I mentioned earlier. You could use a messaging service or the broker that manages the connections or message transfers. You could use the Lambda function. We call this a local Lambda on the edge. You could use the shadow service, or you could also use the machine learning inferences at the edge. So it's a point to note that it's actually, Greengrass is not a device. It's not a hardware. And that sometimes confuses our customers. It's actually a software that extends the cloud capabilities to local devices. So it's a binary that it's pre-compiled for a list of supported hardwares and operating systems, and we can go into the specifications and find out what we support, what are in the works, and things like that. You cannot compile it. We don't give you a compile option to compile, and the platform we don't support that. We have our own binaries that you have to download and install it in the supported hardware. And this enables devices to collect and analyze data closer to where it was generated, and it can react autonomously to the local events that happens, even if communication to your cloud is currently not available. And that is generally the case with a lot of use cases, right, where your edge device is working in a condition which does not have enough bandwidth or does not have internet connectivity. Think about condition stack a oil rig where you want to process this data in the edge, and that's where Greengrass comes in. So in the rest of the talk, we'll be going over these building blocks of Greengrass, which are listed here, like the message broker, Lambda or local Lambda, device shadow, security, local resources, machine learning inferences, connectors, secrets manager, over-the-air updates. And so let's look at some of these. Message broker, right? So what is this? It's a broker. Think of it as a service that manages a routing table of source and destination of messages. Like Greengrass can maintain a list of input sources, which could be messages in a topic in the cloud. Right? You could have some cloud application send a message to a topic. So cloud can communicate directly to a device, right? Topic in a cloud, or it could. So your source could be topic in the cloud, and destination could be a Lambda function at the edge, or it could be a machine learning inference where you're sending the inputs to take a decision, right? Most importantly, it can manage communications between these devices within the network, even if the Greengrass device loses connectivity to the cloud. That's the benefit of the having the cloud or the message broker on the edge, right? And think of it as, again, I said, the best way to think about it is not actually a routing table, but it's easier to analyze it, or you can conceptualize it that it is a routing table. That's a source and a destination, and it routes the messages accordingly. Next up is Lambda. We call it local Lambda because it brings the power of event-based computing to the edge. And you can run a long-running Lambda. Lambda generally have a 15 minutes SLA, but you can run long-running Lambdas on the edge to process incoming messages from your devices, right? Think about a use case where Lambda functions, let's say, are reading sensor data. Like you're reading sensor data for temperature sensor. Like Jeremy just showed a use case there. You have a temperature sensors, and you would like to check the temperature, whether it's above a certain threshold or not. And if you see that the temperature is above a certain threshold, then you trigger a Lambda function based on the incoming message and take some actions around it, and then decide whether that message should be sent to the cloud or not. So that's event-based computing on the edge. Now we can also access local resources, such as a serial port, or even a local drive. Or you could also have machine learning models stored locally on the Greengrass host and trigger those based on activity. Let's say an image comes in, you have a computer vision algorithm, computer vision model sitting on the edge. As you see a car pass by, you take a license plate, you take an image of the license plate, and I want to process whether this license plate is legit or not. Then you can run the model, but the Lambda that triggers the machine learning model was triggered by a message that comes in or an image that comes in. So that's the event-based programming paradigm. Moving on to shadows. Again, it has the same functionalities that you have in the cloud. It uses command and control operation model. Now, if your devices are unable to connect to the Greengrass device, then you can store the states of your devices. So there's a concept of Greengrass core and Greengrass devices. I'm coming to that in the next couple of slides. I think that's actually the next slide itself. So that will be important. So you have a Greengrass, the device, which is the heart of all this communication, and then you have all these devices, your sensors, temperature sensors or actuators, and all these are your devices that are connecting to Greengrass. So if your devices are not able to connect to your Greengrass core, then you can temporarily store the state of your devices and update the state when your communication comes back up, right? So Very similar functionality that we saw in the cloud as well. But the best part here is, even if you don't have connections to the cloud, you can manage all this locally. So let's talk about Greengrass core. This is very important. Greengrass core is the heart of all Greengrass communications. Like, it is the command center. It manages all communications between all your devices. Right? It triggers the Lambda functions based on whatever you have set up in your routing table, or the subscriptions that if you're set up. As you can see, it's actually a software. Now you download the core, the whole bundle, into a supported hardware. We currently support x86 and ARM processors, and with Linux, Ubuntu, or Debian operating system on it. So you have to download it into all these supporting environments, and then core would be the one which is managing all the communications across your Greengrass, all the different components that we are talking about, right? Now, there are several APN partners who are building hardware support for Greengrasses. You'll have the Greengrass comes inbuilt on those. In fact, Raspberry Pi Foundation is planning to integrate the core, Greengrass core, in its upcoming releases, which is super exciting news for me. I mean, this is great. Local resources. So what is that? Now, as I said, the Greengrass software, the core, it can access local resources such as your local disk, right? Or the serial ports. It could also be maybe a Raspberry Pi's general purpose IO pins, or even a robotic actuator arms GPIO pins. So if an activity happens at the robotic arm, it moves, you take an action based on that. You could also access the machine learning model that is stored in the local resource. You can also access secrets manager, and I have a slide which talks about secrets manager in detail. So in general, you could store your secrets, your private keys, your tokens, your passwords encrypted in a secrets manager, and then access it from there. So your secrets are also stored as local resources, right? And then let's talk about security. So security is ground zero for everything we do at Amazon. All the communications between devices and the Greengrass and the cloud via your IoT core, it's all encrypted, right? So it supports TLS mutual authentication using X509 certificates. Now, one has to create a Greengrass role and policies to control device access and provide authorization to what you can access and what you cannot. And then Greengrass core, I mentioned, the heart of this whole communication channel, it has its own root certificate, CA certificate, that is used to sign the device certificates. So, but having said that, right, security is a shared responsibility. We will take care of security of the cloud, and users of our cloud have to take care of security in the cloud. Right? What that means is, you have to make sure that you have the right policies in place. You have secured the policies by making sure that only the right users can access it. Right devices are the ones that you can have access to. So, it's a shared responsibility. Moving on to machine learning. Now, you can also have access to machine learning models directly from your Greengrass core. Right. So we support some of the most popular deep learning frameworks, such as MXNet and TensorFlow. So you can build a deep learning model either in SageMaker, or you could bring it from, if you already have a model in place, you could bring it in. And then, if it is MXNet and TensorFlow, we have the frameworks in place, so you can run those binaries here. Or you could train your model in the cloud using Amazon SageMaker and deploy directly into your core devices. And I'll show you once when we go through the walkthrough how easy it is to build a model in SageMaker and then deploy it directly on the edge. Next up is Greengrass connectors. It was launched back in 2018. Now, this allows you to run small targeted applications from your Greengrass core. So what that means is, like, for example, you have a application that sends messages to a Kinesis Firehose application, right? So you could use the Kinesis Firehose connector to process the data directly from these devices and send it over to Kinesis, right? So, and there are multiple connectors, and this list will keep on growing. When I show you the list, you'll see there are about 15, 20 services right now, and then you'll keep on, not services, applications, but and then you'll keep on adding more. There are a few machine learning object detection and classification connectors as well that are very useful. You don't have to create a binary and containerize it and bring it over here. You could directly use the machine learning connectors to invoke a machine learning inference that is stored in the cloud. You could also connect to third-party devices, third-party services. Like we have a use case where, let's say you want to make a call based on the temperature on the device. You want to directly make a call to someone. You could use the Twilio's voice call service, and you could use the connector. We have a connector for Twilio. So these devices, the Greengrass can directly call someone to take an action. And then there are multiple third-party services as well that we have integration with. Secrets Manager. People who have worked with AWS Secrets Manager know it's our service that helps you store secrets, passwords, private keys, tokens, and you could store those secrets in AWS Secrets Manager and have an encrypted copy of that locally on your Greengrass. And then those can be used to access services like Twilio. Now you'll need the token for that. You can use that. You could use the secrets to connect to a DynamoDB database. So it has integration with Secrets Manager. So you don't have to keep those secrets in plain file, right, in your Greengrass device. And then you can also rotate these remotely from your Secrets Manager. So whenever you're ready to rotate those, you can remotely on the Cloud Console, you can rotate them and then deploy the new secrets as part of your Greengrass deployment next time when you upgrade the Greengrass, right? So, and that's where over the update comes in, over the air update or update agent comes in. What that lets you do is update your Greengrass binaries, the configs, your subscriptions, your routing tables, etc., remotely from your AWS console. Now, people who have managed device fleets and manage the life cycle of multiple devices remotely, and then through remote gateways, they would appreciate the benefit of having a central console where you could manage your fleets of devices, right? Or even deploying a new machine learning model based on the data sets that you have on the edge. You want to retrain the model, and then you want to deploy a new version of the model on the edge. Could use over-the-air updates for that. And that saves us a lot of time and management overhead. So those are the building blocks. And there's one more component talk about, which is the Greengrass group. So now we talked about all these different pieces, like the resources, the local resources, connectors, Lambda functions. Now, all of this together makes a group. So a Greengrass group is like a collection of settings and components, such as the core, devices, and subscriptions, right? So the group is used to define a scope of interaction. Like only those components that are part of a group can communicate with each other. So your devices that are not part, so your devices have to be part of a group to communicate with that core. So you can only communicate to the core if you're part of that group. Now, your devices can be part of multiple groups, but you can only have one core in one group. So as I mentioned, core is the heart of the whole group. And so let's say, for example, you might want to represent a group. If you have a smart parking garage and you have multiple floors of parking spots in there, you could have multiple sensors on one floor trying to find out whether there is a car on that particular parking spot or not. All of these sensors could connect to one core. And then all these sensors, all the cores, and the Lambda functions that processes, the machine learning that processes the license plates, all of that together could form a Greengrass group. And there could be one group per floor. Right? So that's how you use this to define the scope of your interaction within a set of components. And you can have multiple groups, of course. The Greengrass group consists of these items. Like, you'll have your Greengrass core, which manages all the communication. You have multiple devices or even microcontrollers, the FreeRTOS based microcontrollers they could connect to Greengrass using the communication APIs that we provide. You could have the machine learning models that this Lambda function that is part of your group can invoke. You have all the connectors, those applications that you can invoke to, let's say, make a call to Twilio, and then all the resources like your local drives or GPIO pins, things like that. So you can, all of this together will form a group, and that makes that completes one logical grouping of all the resources in Greengrass. So that's Greengrass for you. But just to summarize, what is Greengrass? Right? Greengrass it extends the AWS IoT functionality to the edge, so you can act locally on the data that these devices generate while still using the cloud for your management and analytics services if you want to send this data over to the cloud. With AWS Greengrass, connected devices can run your Lambda functions, execute predictions based on machine learning models, all of them in the edge. Right? So that's Greengrass in less than about 30 minutes. Now, one other service I wanted to highlight before we get into a reference architecture and show you how Greengrass fits in the overall picture is AWS Snowball Edge. Snowball, as some of you might know, is our petabyte scale data transfer service. Right? It allows you to transfer petabytes of data from your local data centers to AWS cloud. Now we have added the power of compute on these devices. So you actually, these devices, the Snowball Edge device comes with a purpose-built Greengrass device. So you can run edge computing on this device. As the data comes in from your, let's say, historians, you can run compute on those on the edge itself. You don't have to pay for the transfer charges, or even if don't have to pay the storage cost as this data comes into the cloud. So you can only store the ones that the data that you want to send it to the cloud. Right? So that's a new service which uses Greengrass. So I thought it was worth mentioning, right? And GE uses this today for their wind farms. So wind farms are all in remote locations. The data generated by these wind farms, they download it in a Snowball Edge device and process it right there. And then whatever inferences, insights that are generated, those are the ones that are sent back to the cloud once these devices are ready for, or they send these devices over to their base. Yeah. So the many use cases for a Snowball Edge device. Let's talk about the reference architecture. And It's a very busy slide, but I'll break it down for you. There are three main sections here, right? On the leftmost, you see the gateway. That's where your devices or the so-called things, right, can directly connect to AWS IoT Core using the IoT SDK that we provide. And it uses, TLS mutual authentication, then uses IAM roles and policies for authorization. And then these devices can directly connect to the core. Then you have your microcontrollers, FreeRTOS devices. They can connect to the Greengrass using the IoT SDK again. On the top, you'll see the options for having your industrial devices and machineries that can connect to IoT using OPC UA. So you have your OPC UA servers using the OPC UA protocol. They can send their data to a historian, and you could use the IoT Sitewise or IoT, the industrial IoT service to process the data and send this over to AWS IoT. Now, what I wanted to highlight here is that you see Greengrass also as one of the edge component, but not all data needs to go through Greengrass. Right? You only need Greengrass if you want to process the data in the edge. Right? You see those options here. Your things are directly connected to IoT Core, right, over MQTT. You have the industrial devices using OPC UA connecting to Sitewise directly. These FreeRTOS devices are using SDK to connect to Greengrass. So Greengrass is used only when you have to process these messages in the edge, or you want to have a compute capacity on the edge, right? So that's where it fits in the edge. Then further to the right, there is this AWS Cloud, which we are just highlighting the IoT services. Once the data is in the cloud, you can use your IoT Core to trigger various services, like using the rules engine. And then you have a device management service for managing the life cycle of the devices. You could use a device defender to detect anomalies as the messages come in and create, take some action based on if you see that the temperature of a particular device is really higher than usual. So that's device defender for you. And also you can process these through IoT analytics to run analytics on real-time analytics on messages as they come in, right? So those are some of the options you have. Now on the very right, which we call the enterprise sections, where you have all these different other services that are integrated with IoT. SageMaker for machine learning. If you want to process the data in a data warehouse, you have integration with Redshift. If you want to store the data, in a NoSQL database, DynamoDB, there are multiple options to process the data. So that's how you would typically build a IoT application. Messages coming in from your edge, some of them will be processed on the edge, and the processed data is further sent on to the IoT through IoT Core to the cloud, where you process the data, generate multiple triggers, and then take action on this on the enterprise side. You can, using multiple tools like SageMaker, QuickSight, Redshift, things like that. All right, I think we're about 45 minutes in. Let me quickly go through a walkthrough of the Greengrass console. Let's see. You guys can still see my screen, right, Jeremy?
Yeah, you're 5x5 here, man.
Awesome, cool. Okay, so let's look at a walkthrough. So this is the AWS console, and you can from all the services, there's an option for the IoT service. You can select the IoT Core, and this will bring you to the IoT console. And Greengrass is, of course, a part of IoT, so it's part of the same console. So you can go to Greengrass. Under Greengrass, you'll see the multiple options here. You can get started with a new group, but I have a few groups that I've created and cores and devices. These names should be familiar to you now. So let's go to groups. And I have a group here that I wanted to show you, which is the Deep Lens group. Some of you might have heard about Deep Lens, right? Deep Lens is our deep learning enabled video camera. It says an edge device that helps you run computer vision algorithms on the edge. So it's a packaged hardware that has a high resolution camera. It has a CPU. It says actually GPU, high compute GPU, and then you can run machine learning models. So you have a couple of frameworks, deep learning frameworks inbuilt. So you can build the model in SageMaker and deploy it directly from the cloud over to these devices and run computer vision algorithms. So this uses Greengrass, right? So it is one of the is a deployment for one of my deep lenses. As you can see here, it has all these building blocks I talked about: the core, devices, Lambda, resources, connectors, all that. So core is the heart of it. You have the core that stitches all the connections. Let's look at subscriptions. Subscription is a routing table. As I mentioned, is a source, target, topic. And each of these source and target is tied by a topic, which is again your publish subscribe programming paradigm, right? So you have publishers and subscribers connected to these topics. Then the devices. Now here, the only device for Deep Lens would be the camera that is tied to this particular device. But if you build your own group, you can have multiple devices, and each device will have its own certificate, and they will be signed by the root CA certificate that comes in the core itself. The Lambda functions are the ones that are triggered based on activity. So in this particular case, I have a Lambda that has detected a face in a computer vision algorithm, and that will trigger the Lambda function to take an action on it. And then these are some admin Lambdas, but pretty much this is the only model I have deployed here. It detects faces as it passes through, and if there's a person in it, it will trigger this Lambda, and it will call a machine learning algo that is deployed on this Deep Lens, and then you can run your computer the face against this model and take an action, whether it's a male, female, whatever. The resources, local resources. I need access to these drives. Like for the GPU machine, I need access to these local drives. So you'll have access to these. Machine learning. Right now, I don't have any machine learning model. This is just the group. Once you can add a machine learning model in here. Now, the things that I want to show you is integration with SageMaker, right? So upload a model from an S3 bucket that you could do. You could provide a location of an S3 bucket where you have a model stored. Or if you have trained the model in AWS SageMaker, you can simply go to the machine learning model that you have built, and then it will download the binaries or the artifacts from your, it's actually stored in S3 as well. But since it is directly integrated with S3, SageMaker, it will go and find out which S3 bucket these artifacts are stored, and it'll bring it down here and create it'll be part of the Greengrass deployment. And then when Vijay shows you, he'll show you how those folders are created in your machine. Okay, moving back to resources and then connectors. So as I mentioned, connectors are small applications that can process, a point use case. For instance, in our case, I was talking about Kinesis Firehose. If you want to send the data to Kinesis Firehose, or if you want to process image classification on an ARM processor, or object detection on an ARM processor, and the third-party notifications tools like Twilio or even Splunk integration, ServiceNow integration. So you could send this data directly instead of building an application from scratch. Right? All right, so let's see. Yep, and then this is your group, as I mentioned. So you could have the group certificate. You specify how often you're going to rotate the certificates, and manager stream is used to stream data more efficiently from your device to the cloud. So this is your group, and all the cores and the devices that are connected to it will be part of this. So you can have multiple groups. As I mentioned, you can have only one core per group, and you can have multiple devices connected to that group, multiple machine learning models, multiple algorithms, multiple Lambda functions, and then you can have multiple groups, and a device can be part of multiple group as well. All right, so with that, let's go look at a demo, look at an implementation of Greengrass, and we'll be using we don't have an actual device to install, but we'll be using an EC2 instance as a simulated device, edge device, where we are going to install the Greengrass, and then we'll show you how it interacts. So I'll hand it over to Vijay. Vijay, you want to take it over?
Sharing screen. One more second. Can
you're breaking
go
up a
with
little
the
bit.
well? All right.
Yeah, better.
Great. Neil, is it okay?
Yes.
All right, cool. All right, guys. So very quickly before we get started, I just want to introduce myself. My name is Vijay. I am a TAM based out of Phoenix, Arizona, and I have been with AWS for a little over 1 year. Prior to AWS, I have been mainly working in the enterprise infrastructure space. So before the cloud, as in the public cloud, I was mainly trying to build private clouds for the enterprises. All right. I like to tinker with microcontrollers, Raspberry Pi, Linux, and a little bit of Python. And IoT is an area that I'm exploring in development perspective. So with that, share what we are going to go through today. I hope you guys can see my screen with a small note. So the plan is through Greengrass and at more
I don't know if it is just me, but I am having a hard time listening. Is that the same with you too, Jeremy? Never mind, I think.
Yeah, I'm having a problem hearing you too, EJ.
Okay.
It's better now. I don't know, once in a while it
All
just...
right. Maybe I was moving around a few things. I will go slow now and not to move too many windows. Okay. So the demo is on GitHub. You are welcome to go and explore this on your own time. It does require you to have an AWS account, and all the prerequisites are noted here. Please note that there could be a little bit of charge on that account when you spin up these resources, and you may not be completely in the free tier. So just be mindful of that. So the high-level agenda, I will give you a walkthrough of this particular lab. Then we will go through a few demos. I will explain you a little bit of Lambda. I know Neil has already covered this, but just as a touch base, because we will be deploying a Lambda function on a Greengrass edge device. And then we will wrap it up, right? So on this GitHub, as you can see, this is the basic topology that we have. Starting from the bottom, we have two end devices. These are the IoT devices named as GG80 and GG80, and they are talking to the Greengrass over MQTT protocol. And the Greengrass edge device itself has a connection back to the AWS IoT core. The way this is done is the communication based on this architecture here. We have many ways to configure subscriptions to route messages from GG80 to 2. It can be direct and also from GG80 to the AWS cloud and vice versa. That means you can send messages from the cloud to the end devices as well, as this is a bidirectional communication. We will also go ahead and deploy a Lambda function on the Greengrass edge device and let that function do, write some messages on one of the topics that we can validate on the IoT core. All right, so that's the plan we have. So before I jump into the AWS console, let me walk you through how this has been set up. So I hope my AWS console is visible. On AWS console, if you go to services and search for IoT, and you can click that, it will take you to the IoT service. And within the IoT service, it will take you to the landing page. I think Neil has, oh, sorry, the session has expired as always during the demo.
So Vijay, while you wait, I am reading the comments on the section here. I see some folks are having issues seeing the GitHub. It's a Robert mentioned that he can see only part of the GitHub page. So maybe you want to full screen it.
Okay, I was trying to basically, how about this? I share the GitHub link in the chat. I'll post it here.
Yeah.
So I hope Jeremy and Neil, you got it. Maybe you can share with the audience.
Yeah.
Yeah, that'd be awesome.
The reason for that is I probably will not be going and referring to this GitHub page that often now.
Okay.
But more importantly, I hope everybody can see the console, and I will be bringing up my terminal soon. Okay. So I'm going to open the IoT core, and I'm also going to open EC2. This. I think my laptop is a bit slow and it might contribute to this audio quality. Okay, so once this loads up, you can see I have two EC2 instances running. So these are basically virtual machines in the cloud. And on this particular instance, which is named as GG Amazon Linux 2, this is where the Greengrass edge computing software is deployed and running. And on this other, the other EC2 instance, I have deployed my two clients, which is GGAD1 and 2. So switching to the terminal, I will now connect to the first EC2 instance in the console and change directory to GGAD1. And I will do the same for GGAD2. All right. So what this is, and if you go through the GitHub, you will, you will know how to do all this. So you will understand how to do this yourself. But basically, if you see, I have some scripts here. So one of the script is start direct.sh. So if I execute that script, what it does is it starts publishing messages. The message itself is hello world. I'm just going to stop it so you can read it. So the message itself is hello world, and it is published to the topic SDK test Python, SDK/test/Python. And the way I can check that is if I navigate back to the IoT console, and there is a test function which is inbuilt into the console. I have opened that in a new tab. And once that loads up, it's just unusually slow today. Probably my local machine. So, and I can subscribe to the topic from here. As you can see, I have given that specified SDK test Python and click on subscribe. And you will see the hello world messages are being printed here. And so this is continuing to happen. So, and the last sequence was 70 before I stopped these. And you will see the last message is here, 70 as well. So what this is demonstrating, so if I go back to my notes here, sorry. Yeah. So what we have done a demo is device to IoT core communication directly. So this script is configured to send the messages directly to the IoT core. It's bypassing the Greengrass edge device right now. And I can do the same from Greengrass too, but for sake of demo, we'll move on. Now, the second step would be to check, do the same communication via the Greengrass now. So let us jump onto that. And I'm going to start the second script, which is named as start greengrass.sh. And it will start pushing messages to the Greengrass. And I will do the same from the second device as well. All right, so while that is running, and if I go back to the terminal here, let me clear these. And you're seeing there are no messages here. So let us, before I dive into that, let me show you how the Greengrass is set up. Now, Neil has already showed you some of this, but what I have here is a group called GG Group 2, and I have devices, which is GGAD1 and GGAD2, which I have already added to this Greengrass deployment. And if I go inside this group, you can see those devices have been added to this particular group. If you look at subscriptions, there are no subscriptions. And for that very reason, let me open the test tab again. For that very reason, because there are no subscriptions, there are actually no messages coming to the IoT core. And that's the reason why when I started the script via the Greengrass, there are no messages being shown here. So in order to make that happen, is configure subscriptions. So I'll go and add a subscription. And let's say this subscription is from device GGAD1 to the target IoT cloud. Select next. And let's give a topic as SDK test Python, because this is the topic these Python code is actually pushing the hello world message into. And let me finish. Once the subscription is done, you need to go and do a deployment of this subscription. And when I click deploy, the deployment starts. So right now it's saying it's pending. Soon you will see it's in progress. And very soon the deployment will finish. So let's wait for that. Cool. So once the deployment is done, we should start seeing the messages come here. Yeah. And this particular, Python is it's not sending hello world. It is sending some random temperature, humidity, and all that pressure data. And it's also printing the device name there. So you can see the GGAD1 is being printed. So we know it's coming from GGAD1. All right. And this is all controlled by the subscription. So what's happening is you're not seeing any GGAD2 there. And what if we want the two sensors to communicate? What if we want GGAD1 to send the MQTT? We want the MQTT messages routed from GGAD1 to GGAD2. So let us do that. So we go back to subscription, add a subscription. In the source, we give GGAD1, and in the destination, we select GGAD2. Click on next, and the topic would be the same. And finish. And last, we need to go and deploy this. Let's wait for the deployment to finish. And as soon as the deployment is finished, you will start seeing, yeah, it has already started here. So let me stop the script here on GGAD2. So you will see the GGAD1 messages are being printed on the GGAD2 terminal. And the reason for that is the subscription we have configured. Okay. All right. So let's go back to our notes. And so we have done demo 1 complete. We have done demo 2 where we are doing device to IoT core, and device to device via Greengrass. So that is good. Now, how about cloud to device communication? This can simply be done by going to, if we can go to subscriptions and add a subscription, give the source as this, IoT cloud, and the destination as GGAD1. And give the topic as the same SDK test Python. Finish. And so we have this GGAD1 console. So we have to watch the message there. But in order to push messages to a topic, we have this handy option of publish message. And if I go to publish to a topic and a topic name, test Python, and I'm going to click publish to. Oh, sorry, I did not do a deployment. Right, so I did this, but I missed doing a deployment. So let me do the deployment. So let that finish, and then we are ready to send the message from the cloud to GGAD1. So I'm just going to resize this a little bit here. All right, so the deployment is complete. And publish message, publish to this. It's actually hard to say. The message must have, because it's quite verbose. Yeah, here you go. So the message is here, hello from AWS IoT console. So that's great. So we have like device to device communication, device to Greengrass, device to IoT core via the Greengrass, and from IoT core to device, all happening seamlessly. All right. So the next phase of this demo is to go through the Lambda provisioning. Now, Neil has already given you some idea about what Lambda is, and apologies if you already know about Lambda, but I just thought while we are doing demo, it's a let's quickly refer this. So, I mean, this is just AWS documentation. I'm just going to post it to Jeremy to share with you if you want to, but it's quite easy to search it in a search engine and land to this page. So what is AWS Lambda? It's basically a AWS compute service that lets you run code without provisioning any servers. So you can run code. Now, in this particular case, what's happening is you're running this function on the Greengrass edge device. So in our case, it's running on the edge device, which happens to be the EC2 instance where the Greengrass has been deployed. But it could very well be a Raspberry Pi or any other ARM or Cross-86 based device on the edge location. All right. So I will let you guys go over the Lambda at your own pace. But in order to show you the demo, I already did create the Lambda function, and if I will give you a link after this to go and, I mean, obviously the workshop walks you through it, so you can follow that to deploy the Lambda function yourself. I have already deployed it. All I need to do is once the function is deployed in the Lambda console, I go under the Greengrass. Actually, let me use this tab. And if I go under Lambdas, you need to actually go and publish that Lambda function within the Greengrass group and then do a deployment. So let me go and add Lambda. And I'm going to use an existing Lambda function because I have already done that before today's demo. And the name of that function is Greengrass Hello World. Essentially, that is what it is doing, printing Hello World. And I'm going to choose an alias of the function. So as you can see, that function Greengrass Hello World shows up here. I will go ahead and edit this function to make some changes. As you can see, you can change the memory limit and the timeout, etc. here. So you can specify how long this function should run for. So I'm going to change this from 3 to 30 seconds just for demonstration purpose. But 3 seconds is more than enough for a hello world to be printed. Memory 16 meg is fine. And I'm going to change it from on demand to make this function run in a loop indefinitely, because I want it to be keep printing those messages. All right, with that, I'm just going to click on update. And with that, my function should be good. And as with everything, I need to do a deployment. But before I do deployment, what is going to happen is, even though the Lambda function is running, it's not sending any messages to anywhere. And the reason for that is subscriptions. So let me go to subscriptions and add a subscription. And in the source, see, you can see the Lambda here, which we recently configured. And the target will be IoT Cloud. Click Next. And the topic, that Lambda function is hard-coded to publish to this topic, hello world. So the Lambda function is done. The subscriptions are done. The only thing remaining is deploy. Let's watch the deployment. Cool. So the Lambda function is deployed. I hope now we should be able to subscribe to that topic, hello world, and start seeing the messages. So I'm going to choose the topic, hello world. Yeah, great. So as you can see that hello world, and the message is coming from the Greengrass code running on platform Linux so-and-so, which is Amazon Linux 2. So this successfully, we are getting printing messages from the topic. And you can also see this is running in a loop based on the preference we have chosen. All right, so that concludes the demo. We have gone through all the topics here. We'll be passing it back to Jeremy.
Thanks, Vijay.
Awesome. So I'm going to post all of the links in the post show notes. I want to thank Neil and Vijay and AWS for coming over tonight.
Yeah, so
Neil, any parting
one
words for us?
last slide I wanted to share with you all. If you guys have my screen on, you guys can see my screen, right? If you want to learn more on IoT in general or AWS IoT, the number of training curriculums we have, there is a IoT focused foundation series with multiple trainings that takes you from beginners level to intermediate level. Just search AWS training and you'll see those options. There are more than 25 free digital courses. They'll cover topics that we discussed today. Greengrass, one of them, and you'll also have IoT core, analytics, device management, events. You can go over all of that and get started on that. So thank you for your time today, and looking forward to you all using Greengrass.
Awesome. Well, I want to thank Neil and Vijay for coming out tonight. Special thanks to AWS for building awesome systems. I'm in mine every single day, so no question, it's awesome. Want to remind everyone that next week we'll be going over the basics of HTTP communications, or GET, POST. We're going to take it down to the bare minimum and do some grassroots training. So we'll also talk about a little UDP in there and the difference between that and TCP/IP. I want to thank everyone for coming out tonight. Again, thanks to our awesome sponsors, Pratt Miller, our awesome team on the board here at Charlotte IoT, our friends over at Riot. They've got both Atlanta and Raleigh organizations that are just blowing it out of the water. Please take a look at their lineup of amazing lunch and learns. And if you've got any questions, again, post them down below the show, and we'll definitely be getting back to you. Again, thank you everyone for showing up, and y'all have a great night.
Thanks, everyone.